All right. Welcome, everybody, to the Hobby CNC with Dave show. I think we got a good one for you tonight, folks. Let me bring in my sidekick, the Wolfman here. He's going to be looking in the chat, looking for your questions. If you have any questions tonight for me or my guest, just put a Q in front of them, and that'll make it easy for Ryan to spot, and he'll tag them, and we'll get to those a little later in the show. But first, I'm really excited to have my guest tonight. He's a co-founder of CNC Labs. Please help me welcome Mr. Andy Lee. How you doing, Andy?
Hello, hello.
Let me. I'm going to switch everybody around here because I want to get. There we go.
Oh no, my face is so big. I should have put some makeup on.
All right, we're good to go here now. I'm excited to have you on the show because, as we talked earlier, I said, every time I'm in a Facebook group and somebody new, joins the group and they say, "Hey, I'm new to CNC. I'm looking for one. What should I get?" And the LongMill always is one of the choices that people throw in there. I see that a lot, and I thought at one point, well, I've heard that name a lot, but I really don't know that much about them. So I'm gonna dig in. And when I started checking them out, mostly on YouTube, I thought, well, I'm gonna reach out to your company there and see if somebody wants to come on the show and talk about the LongMill and really everything that you guys offer. So thank you very much, Andy, for agreeing to come on the show. I appreciate it very much. And I know I have lots of questions for you. I'm sure our audience uh, will as well. But before we get started too deep into this, just if you would kind of tell me a little bit about the beginning of CNC Labs. I mean, was this kind of like the classic story of two guys starting a company in a garage, or tell us a little bit about that?
Oh yeah, 100%. So yeah, I guess I've told this story quite a lot of times, but here it goes. So me and Chris, my co-founder, we're both from the University of Waterloo. That's how we met. We're first year. We met in first year because we're in the same class. I don't know if you guys know, but we have a co-op program. So it means that we do internships in different companies every year. One of the jobs that I had basically builds CNC, sorry, not CNC machines. They build these machines that handwrite, and then the machines handwrite letters, and then they use it for like direct mail advertising. Um, so, so one of the clients that they had were like the Conservative Party here in Canada. They wanted to canvass, they wanted to get more votes for their party, so they would send out these letters. And obviously, if you handwrite all those letters, it takes a lot of time and a lot of hand power. So machines was a solution. What we did was use these Shapeoko 2s with pens attached to them, and they would like handwrite the letters because we would use software to control the machines, and then they would spit out the letters. And basically, my job was to run the machines and make sure that they work. And part of the job was for me to get an understanding of how the machines worked and also design new parts and machines to replace those Shapeokos. I also had another job before that where I was a CNC programmer as well. So with those kind of experiences, I was like, oh, CNC machines are super cool. I like the ability to be able to create stuff without having to use my hands and make parts that are super precise and repeatable. So I started to gain more understanding of the machine and the process, and I was like, oh, I can build my own machine now, so maybe I should do that. So when I went back to school, at that point I would have gone into, I think I would have finished my first year of engineering. I started prototyping some machines, and because Chris was my roommate, he would also help me. He also had the 3D printer and he had a ton of tools. He was super engineer. He was like the stereotypical engineer, has a 3D printer in his room, has all the tools, makes stuff, breaks a bunch of stuff, and all of those things. And he helped me a ton to start to prototype these designs and these machines. And we would go to the machine shop and make stuff. And at some point, people were interested in buying the machines or using them for their own applications. So we thought, hey, maybe we could build the machines and sell them to people. So at that time, I also was taking an elective for business and entrepreneurship. And one of the things that we had to do was to kind of model the assignments after a fake company, essentially. So my fake company was, okay, we're CNC Labs, we build CNC machines, and it's not a real company, but we're actually making stuff and we're modeling after it. And it started to kind of make sense. So, we could build these machines and sell them. So, things snowballed. I didn't find a co-op job into the next term for a number of reasons. But during that term, the option was, oh, you can work for yourself to get an internship credit, and why don't I just run with the idea? And by the end of that term, we had launched our first Kickstarter for the Mill One, which was the small, roughly microwave size CNC machine, and we actually raised around $60,000 to build those machines, and that's kind of how the ball started to roll. So yeah, we were in student residence at that time. Me, Chris, and a couple other engineers rented a house near the university. We did have a garage. We would get the parts into the garage and we would put them together. We also had a 3D printer farm in the laundry room. I think there was like a shelf of 8 or 9 3D printers, because we would 3D print a lot of the parts for the machines. And then we would just, pack them into baggies and, make the kits and figure all of that stuff out. Some of the parts we made at the machine shop, some of the parts we started to learn to outsource. And it kind of just kept growing from there. We started off by, building a couple machines at a time. Eventually, we were making 100 at a time. And once we had gotten to having a couple hundred mill ones out in the world, one of the big things people are asking was, can you build a bigger machine? And we were like, I guess we could. And so we did. And that is how the LongMill came to be. It was basically our customer saying, we like the machine that you guys make. We like the philosophy behind it. We like that it's affordable. We like that it can be put together quite easily. We just want something bigger, because the bigger the machine is, the more you can do with it. Obviously, you guys 100% know that. Mm-hmm. So, and that was like the big tipping point. We built the LongMill and we started to do beta testing. We started to share it. Interest kept growing and growing. And at that time, we were kind of at a crossroads where, okay, we're now at our second or third year of engineering. We're not sure if we should like keep pursuing what we're doing, or if we can like hit it big with this LongMill thing. We launched a Kickstarter, and lo and behold, that raised about just over $400,000. So we were like, okay, I think we're onto something. I think people do like the bigger machine a lot more than the little one. So we started building those. I think we shipped the first one October 2019. And from there, our company has kept growing. And now it's basically like doing a Kickstarter every month. So yeah, it's pretty crazy, but it's great. We're living the life. We both love making machines. We're both engineers at heart. So it's always been our goal to make this technology more accessible. And that's kind of the story up to today.
So you were studying to be an engineer?
Yeah.
Yeah.
So
Did you get your degree?
unfortunately not.
Business
Chris
took
did
over.
finish eventually. He took that time off and then he went back to school for a couple months, and we're juggling all of that. It was like crazy for him. You have no idea like how much effort he had to put into everything. But
Oh, I'm sure.
yeah, he made it out alive with the degree and still uh, running the company. And I am not as uh, how do I say, school
Dedicated
smart.
to the paper.
That's one way to say it. So I quit school and I was like yeah, okay, so when I left school, um so they give you the rankings, right? They'll tell you like you're rank 1, 2, 3, 4, 5, and then I think there's like 250 students in my cohort. I was at the bottom 7, and then all the students below me got kicked out of school because their grades were too low. I passed that term, but everyone that did worse than me left. So yeah, I am not a school smart type of person. I like to work with my hands, and I got a good engineering sense, but numbers are kind of hard to work with.
Yeah. Oh, yeah.
Yeah.
Okay, you mentioned I think that you're in Waterloo, Canada.
Yep.
Where exactly is that? I mean, you're not
Yeah.
too far from the U.S., correct?
Not really. So I guess let me just try to think of some landmarks. So the closest border would be Detroit, Windsor, Detroit. That's about 8 hours away, I believe. 5. Actually, no, not 5. It'd be about 3 or 4 hours away, I believe. So then from there you can go into Michigan, uh, and then there's Buffalo as well. That there's another border, Niagara, Buffalo.
Okay.
So we're
Okay.
close to New York State, Michigan State, I believe, and we're about an hour and a half away from Toronto. So if you're familiar with where Toronto is, that's kind of where we are.
Okay.
Yeah, someone corrected me. One of our students that are working for us. I guess
Nice.
he's watching us. But yeah,
Okay.
Windsor's 3 hours away. So it's pretty close to the U.S. But obviously there is a border between the two countries, so
Hmm.
that's
Now,
also another interesting.
do you ship uh, LongMill machines everywhere?
Yes. So our primary customer base is between U.S. and Canada. I would say roughly it's about 50% split. But we do ship about 10% of those machines outside of the U.S. and Canada. And so far we've shipped, I believe, over 40 countries now.
Okay. Cool.
So yeah, I mean they're kind of all over the place, I guess.
All right. Now I've watched, like I said, I started watching a bunch of YouTube videos trying to learn what I could before tonight's show. And when I watch these unboxing videos, it looks like you've got the packaging down to a science. You get everything squeezed into one good sized box. So there's not, shouldn't be a whole lot of shipping involved, I guess, when you're sending them other places.
Yeah, so shipping is an important part of our business model. So as I was saying, our biggest goal is to make CNC accessible, and one of those is to make it accessible for people to get the actual machine. Currently, there's kind of a couple ways to do it. One way would just be to build a machine and freight it to someone, but getting it freighted on a truck can be very expensive and prohibitive, like if you don't have a pallet jack or a forklift or a way to get it off the truck. And it really, like, there's a lot of complications behind that. The other way, which is the way that we do it, is to be able to ship it with a courier, whether it be UPS or Canada Post or USPS or FedEx or whatever it is, because usually that will be cheaper and it'll be a lot easier for people to get. And there's not as many limitations on where those products can go. The reason why one of the biggest design challenges for us is to get the machine down to a form factor and size where it can be shipped pretty easily. So for the LongMill, we spent a ton of time to figure out what's the best way to pack everything so it doesn't get damaged. We're dealing with a lot of steel and aluminum parts. Some of them weigh quite a lot, so they have a lot of inertia. So if you drop it, it's going to shoot out of the cardboard, right? So we need to figure out how thick the cardboard has to be, what location, the weight distribution, everything, and still keep it under the weight where our driver doesn't drive past our shop every day because he doesn't want to lift all these 100-pound packages, right? So we spend a lot of time to get that all down. We all are also very careful on where the weight goes, even in the design itself. Like there's specific cutouts on the steel plates and all those things that if we can remove weight where it doesn't impact the strength of the machine, those are all like very important factors as well. And the result of that is we're able to pack one machine with a 2.5 by 2.5 or 30-inch by 30-inch work area in one single box that weighs about 65 pounds. And typically it costs about $30 to $50 to ship it in the US, and about that same range within Canada as well. So you get a full machine, you get it in one box at your door, you put it together, and you got a fully working kit.
Nice.
Okay. You mentioned the one y'all started with. I think you call it the LongMill 1. I think the microwave size when you said.
Yeah, it's the Mill 1. Yeah.
So how many different models or sizes are you guys making now?
So right now, originally for the Mill 1, we had just the one size, which had about a 250 by 200 millimeter work area. That we've discontinued because we've just been way too busy with the LongMill. The original LongMill came in three sizes: 12-inch by 12-inch work area, 12 by 30-inch work area, and a 30 by 30-inch work area. However, when we looked at the proportion between the three different sizes, we had less. I think over the last year, we sold 7 12 by 12s and more like a few thousand of the other sizes. The 30 by 30. You can see where the doesn't make sense to carry one where only like a few people will buy it kind of situation runs. So
I get that exactly. Yeah.
Yeah, so we carry the 12 by 12, the 12 by 30 and the 30 by 30 now. And we also have the 48 by 30, which is a new size that we recently announced as well. So those give you, you can fit a 4-foot sheet wide into the machine. And then you can usually what I do is I take the full sheet because I don't want to cut it, or I get like half a sheet. And then I just keep moving it down, and then I just keep cutting out of that sheet until I run out of the sheet, because so that's kind of the idea. So so right now we have three sizes: 12 by 30, 30 by 30, and 48 by 30.
Okay. Nice. And do all of these machines, do they all have basically the same configuration as far as controller and stepper motors and lead screws and all that? Is it just pretty much the same machine, just bigger?
To some extent, yes. So the rails and the rails stay the same, and the motors stay the same, and the controls stay the same. But we do change the length of the rails as well as the bearings and the lead screws if you get the 48 by 30. So on the regular 12 by 30 and the 30 by 30, we're using T8 or 8 millimeter diameter lead screws in the nuts, as well as the NEMA 23 motors. If you step up to the 48 size, what we found is that if we use an 8 millimeter diameter lead screw over a length of 1,500 millimeters, sorry, I guess I'm a metric guy.
That's okay.
I don't know what the imperial. I believe it's like 52 inches. I believe. something like
Yeah,
that.
something like that.
Yeah, 52 or 55 inches. The lead screw whips, so we have to use a thicker one, which is why we use a T12. We've created new nuts, new blocks for everything, and we're using larger bearings for that. So that's kind of the big difference. Otherwise, the controls and the machine is fundamentally the same.
Cool.
Okay. And these are all kind of based around Arduino, correct?
Yep. So we're using sorry, go ahead.
Well, I was going to say, I guess you have, well, I've seen it on your website. I guess you call it the longboard controller. Just talk about that briefly, if you could.
Sure. So the longboard, at its core, using an Arduino Uno as the brains. For people who are familiar with Gerbil, it's just like it runs Gerbil. Then we have 4 TB6600 driver modules. So for people who probably have built their CNC machines, the TB6600 is like 4 amp, up to 4 amps driver for stepper motors. They're relatively inexpensive. We make them into modules so that they can be soldered onto the main daughter board, the long board, and then they all integrate with each other.
Okay. Let's see. When someone orders a LongMill CNC, what is included in the basic package? And I know I've seen your website. You have quite a few add-ons. Can you talk about that a little bit, about what comes with it, and what do people need to get as an add-on?
Okay. So the basic kit just comes with the machine and all the hardware. That also includes all the electronics and stuff like that. So if someone were to put that together, they would get a full machine. There's going to be a couple of things that they'll have to consider getting, either from us or from somewhere else, which would be the router or spindle and the end mills, which we also sell as an add-on. There's a couple accessories that are optional, a dust shoe and a touch plate, and we also have inductive sensors as well. So I guess in tiers of what do you need first, it'd be the machine, and then a router, which is an add-on, the end mills, which is an add-on, and then you don't need but nice to have, and most people get, it would be the touch plate, the dust shoe, and the inductive sensors. We do also sell dust shields for the y-axis for the 30 by 30 and the 48 by 30 long mills. Those are kind of like less people get those, but it's like another nice to have. And we also sell all the parts for the machines on our store as well. So those are obviously, you don't need those, but if you ever do, they're there.
Right. Yeah, I was looking around, poking around the website this evening before we went live here, and you guys have quite a wide selection of router bits on there.
Mm-hmm.
I mean, a lot of times places won't even have router bits. They're just like, yeah, go get whatever you want to. But you guys have a really wide selection of all kinds of. I think it's like 2 pages worth of bits on your website.
Mm-hmm. Yeah, and the reason is because a lot of people ask, what router bits should I get? We can make it a lot easier if they just get it from us, right? So
yeah, exactly. And speaking of making it easier, I just got to give a big pat on the back. I don't know if it's you or Chris or who does the website stuff, but you guys have just a fantastic website. And I'm not talking about how pretty it looks. I'm talking about the amount of information that's on there for anybody that's looking for a CNC. In fact, I'm going to go ahead. I was going to do this a little later, but I'm going to go ahead and do it now. Let me share my screen right quick here. I wanted to kind of highlight this. This is a page on your website where you really help people decide what kind of software they need, because a lot of people that are getting into this, they don't have a clue. They don't really, they they don't know what they need. But I see here you've got a thing where you can come on here and answer some basic questions, and you guys help them figure out, okay, well, if you want to do this, then this is the kind of software you should get. And I just think that's fantastic. I haven't seen that on anybody else's website uh, ever, and that's just a pretty slick outfit. You know, just, like I said, the website's just chock full of information that's going to help the newbie with every step of the way.
Yeah, I mean, where credit is due, that was created by Chris, and we also have a couple of software developers. They work primarily on GSender and a couple other projects that are still coming down the pipeline, but they created that tool. So yeah, if they see the video, I guess they can get my pat on the back and your pat on the back, right?
Yeah, because like I said, it's just, and I actually saw that. I think I can't remember whether it was Chris or Kelly, but one of the video I've watched so many of y'all's videos, I can't even keep them straight now. But one of the videos, uh, I think it was Chris, but I could be wrong. But he was showing in the video, how to go to that website and answer those questions, and you can get, a lot of things that the newbie, the questions a newbie would have answered right there in one spot. So I think that's just a great resource there.
Mm-hmm.
So tell Chris or whoever it was that did it, well done.
I will
Well
do.
done. Well done for sure. Let's see, where am I at here on my questions here? How long, or I guess you might know this, how long does it typically take someone to assemble the LongMill CNC? Say somebody gets your mid-size one. How long should they expect to spend to have to put it together?
So we built a couple of our the Mark IIs ourselves, and we also have, I believe, 3 or 4 beta testers. They generally take about 2 to 3 hours to put together. So with that information, we believe that most customers should take about the same amount of time. When we did the beta testing, those customers didn't have instructions. So we basically wrote kind of like, we would have like instructions drafted, and then we would see, okay, well, if you follow these instructions, how long it would take, or where would people get messed up on, and we would time the whole process. So yeah, generally speaking, it does take 2 to 3 hours to put together.
Okay, that's not bad at all. And anybody that knows me very well knows that I am of a strong opinion that the person that puts together their own machine will be much better at running that machine, at least right on, because when you put it together, you even if you don't know anything about them, when you put it all together like that, you understand, oh, I see why this goes here and why this can't have any backlash, and all that stuff. So I think that that makes a much better operator early on when they have to put their own machine together versus the kind that just ship on a crate and you plug them in and turn them on, and the first time something goes wrong, they don't have a clue what to do because they haven't put any of it together. So
Actually, just to add to your topic, there is something kind of interesting that I learned recently. It doesn't actually matter how long it takes to build a machine. Like, people don't actually complain about how long it takes to build a machine. It's actually the experience that's more important that we found. The old machine, it took about 4 to 5 hours roughly to build, but I don't think we've had much criticism on how long it actually took. The biggest criticisms always came down to, hey, this doesn't fit properly, or why does the order not make sense? I am proud to say that the new LongMill has had a lot more thought put into it. So it's not just the fact that it takes less time to build, but the process is actually a lot simpler, because when we repeat the same process of putting it together across different areas. So for example, all of the motors get put together the same way. So you just repeat the same process 4 times. So So you don't have to like put motor A in this direction and in this with this hardware, and then motor B in this direction and this hardware. They're all put together the same way. And we also try to repeat the same part. So in terms of inventory and stock, the Y gantries are the same. A lot of we only have a couple different types of hardware now, as well as like all the feet are all the same. So rather than having variations of each part, we use the same part over and over again in all like the whole machine, which means that the variety of parts are a lot less. So the experience, I think one thing to point out is that the time of the machine putting the machine together is just the one thing that someone has to do for the first time. But to reduce the frustration someone finds in putting it together, that's the big exercise that we had to tackle.
Yeah, I would agree with that 100%. It like you say, as long as it's not frustrating putting it together, it really doesn't matter whether they can do it in 2 hours or 10 hours. To me, that's always part of the fun. I guess that's just the way I'm wired, but I love putting stuff like that together. In especially like some of the machines I built here recently, I say built, I've assembled them. It's somebody else's design, and I always enjoy putting something else together and seeing how they designed it, and that's just part of the fun of it for me. So let's see here. All right, I looked around on your website and I didn't see a rotary axis for the long mill right now, but is that something you think you might add in the future? I mean,
Well, that's a hotly debated topic.
That it is.
Yeah. I guess there's a couple of considerations that we've been making to prioritize one development over the other. So we do want to build a rotary axis, but we care about more than just building the rotary axis. I believe Bob, from one of your previous interviews, basically said making the rotary axis is like trivial to say, kind of like, you can make a rotary axis like a million different ways, but getting it to work and getting people to use it is a whole different story. And that's kind of like the biggest kind of hurdle we're trying to think about before we start the development. Software is a big part of it. Having four axis CNCing is obviously a lot more complicated than just 3 axes. And because our primary customer base are people who've never used a CNC machine before, we don't want to overwhelm them with, okay, here's another axis kind of thing.
mm-hmm.
That being said, we do have one of our product developers that has said, okay, once I finish this project, I am going to make a rotary axis. So, like, I'm not saying that there will be, or we will sell one, but we get this question a lot, so just know that it's not falling on deaf ears. The other part of it is, okay, if we do build a rotary axis, how many can we sell, and will it make business sense for us as well? Because like I said, most of our customers are beginners and they're just starting out. So we wouldn't recommend them to jump to the 4th axis right away. But we are also finding that a lot of our customers are maturing. They're learning more and more about running the machine, and they're looking for more. So now we're also building kind of a customer base of people who are looking for us to build new stuff for them to play with.
Mm-hmm.
So, there's all those factors to think about. We're not actively developing a rotary axis right now, and it's not been something that's been prioritized. So those are just like our considerations. So you guys can all keep talking to us to make a rotary axis. And if enough people say, get in our ears, then we will, right?
Okay. Well, I wasn't trying to put you on the spot. that was just something I thought of. Now I did see that you do offer a laser attachment. for the long mill. What do you have? I didn't look that close. Do you have more than one, or is it just a certain wattage, or what
Right.
is it that you have?
So we do have a laser. It's called the laser beam. This is a Kenneth's project. He's one of our guys that works here too. He basically came to the conclusion that there's one option is to buy not a super powerful laser from China that has maybe between 1 and 5 watts, and those are very, very cheap. I think you can probably get one for between $100 to $200. Like an Ultra would be a good example. There's not really any reason for us to compete with that because we're a Canadian company. We don't have the ability to compete on price. That's just kind of the truth. However, we can innovate and develop something a little bit better so that for customers that are looking for a higher end laser that still want the support, that would kind of be our niche. So for the laser beam, one of the primary things that Akena was working on was it needs to be the most powerful diode laser you can get. Well, not the most powerful, but in line with the most powerful. The limitation for diode lasers currently comes down to the driver, or sorry, not the driver, the diode. The NUB 44 is the most powerful consumer grade diode that you can use for this particular application. And all high power diode laser companies will use this diode to make their 7-watt lasers. So in essence, if you bought a 7-watt laser from company A, company B, and company C, in essence, they're all very similar in terms of power output. So that was like where that's kind of our marketplace, I guess. However, price is the big thing because a lot of those lasers go for $500 to $700 US, or maybe like $8,000 to $1,000 plus for those lasers. However, the laser beam is around the $400 to $450 mark, or about in like the mid 300s in US dollars. So there's a substantial difference in price there. And the reason we can offer that is because we have a lot of LongMill customers, and a lot of people buy the light burn laser. So we have the the scale factor that we can play with. So I guess just to add to like how our business works, we can take advantage of economies of scale in a lot of different ways. The laser beam, we've only sold a couple hundred of. I think we're kind of in the 500 lasers mark, which is a pretty small number in the grand scheme of things. But because we do wiring, we have staff on hand that are highly trained in assembling these type of things, as well as we have a big 3D printer farm, so that we can churn out the parts to build parts for the laser, as well as we have laser cutters in-house as well. We can make all the parts, and we can use the parts that we use in other products that we already make a lot of, and then make small batches using the same materials and parts from those assemblies to have economies of scale throughout the whole product range that we offer. So yeah, we offer the same type of laser for a lot less money, and that's kind of the aim that we've taken with that product.
Okay.
I guess the other thing is, as I was saying, most of our customers are beginners. They're not very technologically savvy. So they just want a laser that works. They plug it in, we give them the instructions. If it doesn't work, they can talk to us. And we only sell the laser, we only have support for the laser beam with LongMills. So that was the reason we built the laser in the first place is because we people just wanted, like, we had so many people being like, we want a laser, please give us a laser. And eventually we're like, okay, fine, we'll give you a laser. So it was just, okay, you got in our ear, you want this thing, okay, we'll build it. So yeah,
Okay.
that's kind of the story.
All right.
Yeah,
Very cool.
Mark says Mark has a good point here. People are usually willing to pay for an accessory that's designed and built for their particular machine. So yeah, exactly like what you were saying.
Yeah, good point.
Yeah. All right. I'm going to take a quick break here. And when we come back, we're going to dig into software. So just to give you a heads up, Andy, there'll be software questions coming up. Hey guys and gals, I hope you're enjoying the show. And if so, let me tell you about a few ways you can help support the show. And some of them don't even cost you anything. First off, you can hit the thumbs up button. And if you're not already subscribed, click the subscribe button. Both of those things don't cost a penny and really help the YouTube analytics. Another great way to help support the show is to send me a YouTube super chat. You can do that by clicking on the $sign at the bottom of the live chat window. And finally, and probably the easiest way, is to buy me a coffee. There is a buy me a coffee link down below in the description. And that is just a few easy ways you can help support the show. I really appreciate every single one of you being here watching. So let's get back at it. All right, let's talk software. I noticed that, again, I've been poking around on your website stuff, and you have some stuff called CamLab. I guess that's a web-based, I think, right?
Yeah. So CamLab, sorry, go ahead.
No, go ahead. Just tell us a little bit about that. Because I haven't played around with that. I have played with GSender, which we'll talk about here in a minute. But I want you to give us the lowdown on the CamLab.
Sure. So this was software that we worked on quite a long time ago. CamLab is basically a reskinned version of Kirimoto. I'm not sure if you guys are familiar with Kirimoto, but basically it's a CNC, 3D printer, and laser cutter software for creating the G-code for those machines. We just took the 3-axis version and then reworked the program to, I shouldn't say we, Chris reworked the program and made it into CamLab to offer it as an option for processing STL files into 3D carvings and stuff like that. To be honest, it's been quite a while since he's worked on it, so I would probably check out Kirimoto because Stuart, who's the developer for that, Stuart is like a genius. He made the whole Kirimoto on his own, and he built his own JavaScript library just to make it. It's nuts. A lot of respect for that guy. I don't know if you guys understand what I'm saying, but just know that what he's done is incredible. But yeah, so Kirimoto is the mother of CamLab. Chris took the original code, reskinned it, as well as made a lot of changes to the process of creating that G code. So it isn't the same as Kirimoto one-to-one. It just works quite similarly. And then now you have like all these different options for doing the web-based cam stuff. Yeah.
Okay. All right. Now let's talk about GSender. I am still kind of new because I've got a Bob CNC Revolution machine, and that's my first real experience in running a machine with an Arduino kind of control. So everything else I've always done with external drivers and Mach 3 and that kind of thing. But I have downloaded the GSender and been taking a look, and I got my little Arduino here that I plug in so that I can play around with it right here. And I got to tell you, I'm super impressed with the G Center. I love the layout. I love that there's, I don't know, it probably wouldn't be a big deal to some folks, but I know what I like to see as somebody who's been running CNC machines a long time, and just the way the stuff is laid out, and certain little bits of information that wouldn't mean anything to somebody else, but it's stuff that I really like. So tell us how the G Sender come about.
So G Sender came about because we had a lot of people needing help with using UGS. If you're not familiar with UGS, it's a G code sending software that's
Yeah, I've
kind of has
I've
the
used
same.
it. I've used
Yeah,
it just a little bit, and then I've used a couple of other G code sender applications, I guess. But when I saw the G Sender, when I started looking into the LongMill stuff, and I saw that, and I thought, oh well, let me download and play around with it. And I thought, man, I really like the way this is laid out. It's a lot. Somebody put a lot of thought into that, and it's really uh, laid out in a nice design.
yeah. So where was I going with this story? Yeah, so when we first started, we recommended our customers to use UGS, and that was pretty good. Like UGS is a pretty good software, but it kind of, as the name states, it's universal, which means, how do I say? You
Basic.
know, not basic. It just offers a lot, and there's not a lot of support for each individual machine, aka the long mill. So we created the resources and steps for people to use UGS, but as our customer base grew, we just needed a more streamlined way for people to operate their machine, and so that's how G Sender was born. Um, G Sender at its core initially is based on CNCJS, which is another CNC software. And then that has been redeveloped and reworked and basically got into the core and rebuilt from scratch to create G Sender. There's a couple of, I guess, like quirks that all G Sender softwares have. Stability is a really, really big thing. You need to manage the computer's computing power to make sure that it doesn't crash or get messed up as you're trying to cut something, because if that happens, your machine stops working. So that's one thing, as well as having integrations for features like touch plates and surfacing and checking your G code, homing, all those things. Uh, we just needed better integration for all of those features. And not only that, when G Sender first came out, we didn't have a lot of products that integrated with G Sender yet. But now with the inductive sensors, the new touch plate, actually, I should mention, we have a new touch plate that we're coming out with soon. And that is like, it's just like a new mind boggling thing. You guys will love it. Check it out next week. We'll have like videos and stuff about it next week. But
Cool.
that sort of like integration to have all the back end math and code to work out like the positioning of the end mill, that's all being worked in the background, as well as stuff like a lot of customers were looking for easy ways to surface their wasteboards. Like for example, I don't know if you guys must have done okay, let's jog the machine left to right and surface my board, or let's make a square and do a pocket operation or a raster operation on the square, and then I'll do my wasteboard. All of that just is a lot of work. So now G Sender has that functionality built in, so that now this operation that everyone does, you can just do it and click of a button. So yeah, the G Sender at its core was just a better way to operate your machine. But as we expand, it'll offer more integration with the products that we develop, more features that help make it streamlined for people to use different features. And even further down the line, it'll offer ability to like download features so that I, I don't know. I don't know what's going to be in GSender. That's more for Chris and the developers to brainstorm. But some of the things I've heard thrown out are like box making, like software, and um, like bit setter stuff, and all of those things. We can, because we have control over the software, we can build those things in as best as we can.
Mm-hmm. Okay, I'm down to just a couple of questions, and then we'll. I think Ryan's probably got some tagged over there. I hadn't looked and see. Yeah, he's got a few of them tagged. Well, let me get to my last two questions, and they're pretty easy. Uh, you guys have been around since what, 2016, I think?
Yeah, that's kind of the day that we consider our like founding date. That's technically the first day of my elective at UW for that business thing I was talking about.
Okay.
Yeah.
Okay. So going on 5 or 6 years now, then I guess. So my question is, where do you see CNC Labs 5 or 10 years from now? What?
Oh boy. Yeah. So I guess in the short term, we want to keep continuing to build awesome machines and focus on that accessibility factor. Um, the long mill, we have the three different types of long mills. We're still battling supply chain stuff to get those to customers as quickly as we can. So we expect that to be something that we do over the next maybe 2 to 3 years. We're also developing the alt mill, which is a more professional grade or industrial grade 3-axis CNC router that'll have a 48 by 48 inch working area. Because now that we have a bigger machine, guess what people are asking for? An even bigger machine.
Well, that was going to be when I said, where do you see yourself 5, 10 years from now? Do you think you'll be building like 4x8 machines and anything like that, or are you wanting to keep it more to a smaller hobbyist market?
Well, it's kind of hard to say. We do love what we're doing, like talking to people like you guys and working with the people that are just starting out and falling in love with having this tool in their shop and being able to make all these great things is really, really rewarding. When it comes to the industrial side, it's kind of a different picture. People are worried about, like, is this machine going to make me money? What sort of online support what sort of phone support can you provide? And the money and the scale grows as well. So we do have our reservations, just because one of the things that's really important to me and Chris is that we do things that we care about and things that make us happy. So we have this debate all the time, which is like, oh, we could do pretty good if we build industrial machines and we take the stuff that we develop in the technology and our process into that market. But is this something that we want to get into? So I guess 5 to 10 years from now, we'll have to see. I do think there are a couple areas that I think are really, really interesting. I also do enjoy manufacturing and working with the manufacturers in our area. We work with like CNC laser cutting shops and like CNC milling shops and things like that have the same type of issues that us consumer and hobbyist CNC operators have as well. Like, we need better control over the machines. We can't afford the machines, or we can't keep amortizing it over 20 years. Or we can't find good tooling. We can't, keep track of the parts that we're creating. All those kind of issues as well. So, yeah, we have our toes dipped in that area. So I guess it just comes down to when and why would we want to do that, I suppose. So I know that's kind of a vague question because it's like we're not sure, but you know,
It's a real answer though.
5 to 10 years is a lot of
Yeah.
time, long
Yeah.
time.
And look where you guys have come in the last 5 years. So
Yeah, I mean, us and the team are a lot of younger people. We're of the younger generation, I guess, compared to most of our customer base, and so um, we're not sure yet.
Yeah. Well, I would say that, and I said this in one of my earlier shows this year, that I think right now there's not a better time for a person to get into the hobby CNC arena. I mean, there's so many great machines out there, like the long mill. There's so many more so many more choices than there used to be. 10 years ago. There's just a lot of people are making them and making good quality stuff. So yeah, if I were you guys, I wouldn't be in any hurry to try to make the big ones because I think you're doing a fantastic job making the kind of machines you are right now. So and there'll always be a market for those. So all right, I got one final question, and this is probably the most important question I'll ask you tonight. Tell us a little bit about your shop dog, Lewis.
Oh, Louis. Yeah, so Louis is kind of a interesting story. Basically, so Louis is not my dog. It's like my friend's family's dog, but he's also like I guess I'm kind of like the godfather of the dog. So um, basically, what happened was I was working from home, or aka the old house that we started the company in, and my friend who was in university couldn't take care of the dog all the time because you need to go to school. So he would just hang out at our house, and then she went to do her master's and was in a situation where she couldn't take care of the dog either. So then he just lived with me for the last couple of years. He's actually back with the other family. He's been with them since December. So yeah, he kind of lives between a couple different people basically. So yeah, we do also have a couple dogs at the office. There's a Slack channel called Dogs of CNC Labs. So right now, there our main dog employee is Maya, who's German Shepherd. She likes to stick her nose in people's crotches.
Yeah. It's
Yeah.
not just hers. Mine.
Yeah.
I have 2 German Shepherds, and they do the same thing. They'll walk up to the FedEx guy and go, boom. It's like, hey.
Yeah. I have a big black lab, and he does exactly the same thing too. So it must be a big dog thing. I don't know.
Yeah, I'm just waiting for the harassment suit to come in. No, I'm just kidding.
Okay. All right. Well, that's all the questions I have, but Ryan's got a bunch of them tagged over here, so we'll try to get through all of these.
Sure.
JR at Trade Skillers Anonymous says, how many long mill machines have you built sold? Looks like a great price point offering for the hobbyist market, and I wish you success.
So right off the top of my head, I don't know the exact number, but it's somewhere between the 3,000 and 4,000 mark.
Nice.
I would say the majority of that happened within the last year to year and a half because it was like slow, and then so I think for this year will be like almost close to double that number. So
Wow.
yeah,
That's
and
awesome.
then from there on might be even crazier. So we'll see. We have to find a new shop. It's kind of getting crowded here. But
Yeah, I watched again a video that Chris was doing. I guess he had like a selfie stick or whatever, and he was walking around, and he started in the parking lot, and then he came in and he showed your printer farm, and all the different things. And then and I don't know how old that video was, but at one point he said, "Now this part of the building, the landlord was in it, but he's gone. He moved out, and now we're taking over that part." So I guess your next step would be to move to a bigger facility, right? Because you're getting pretty close to outgrowing that one.
Yeah, I think so. Yeah.
Okay.
I didn't see the printer farm. What printers do you guys like to run?
Our farm right now currently consists of a couple. We have 4 Prusa Mark IIIs.
Yeah, I was
We
gonna
have
say.
we have somewhere between like 18 to 20 something Prusa Minis,
Nice.
and then we have a small smattering of Anycubic Megas and Ender 3s.
Okay, cool.
Yeah. Oh, and just to show off a little bit, let me just grab something.
Okay.
I almost said, how many Prusas do you have?
Yeah.
We just got these 3-kilogram spools for the farm. So now we don't have to, we can reduce the amount of times we have to swap filament out by 1/3. Or sorry, 2/3.
Wow.
Yeah, that printer farm, we have a guy named Ron. You guys should check out his YouTube channel, the Canadian Maker Project. But yeah, he's got a tough job because he's got like 30 plus printers to run constantly. So
wow.
yeah.
Okay.
Awesome.
Let's see. Bill Jones asked, "How thick is the aluminum extrusion? What size is the extrusion? Is it the same size and thickness for the 48-inch machine?"
Right. So I believe the wall thickness is approximately between 2.5 to 4.5 millimeters. So there's a variation in the thickness of the walls depending on the structure that it needs to hold. Chris is crazy. He did like so much FEA on that design, and to the point where he was controlling the millimeter thickness of different sections of the material. But yeah, it's somewhere between like 2.5 to 4-ish millimeters, depending on what area you're taking the thickness of. And then in terms of sizing, I believe it's about, okay, don't quote me on these numbers. I believe it's about 170 millimeters height and about 150 millimeters deep. But it's not a perfect square.
Okay.
And the size for the the extrusion is the same between any size CNC machine any size LongMill. But I would say that this was designed to work with a high level of rigidity between all those sizes. So we just made it strong enough for the 48, and then the 30 by 30s and the 12 by 30s are stronger than they need to be, I suppose. The new extrusion is up more than 50% more rigid with less weight than the original design.
Nice.
Yeah. So
okay.
that had a lot of engineering go into it.
Okay. Clyde, he's a fellow Canadian there. He's asking where you get your aluminum angle.
We've had a couple of suppliers. We get it from Extrudex, which is in Woodstock, I believe. We also get it from Almeg, which is in Brampton or Mississauga. And then we get small batches from Canada Steel in Cambridge. So a couple different places.
Okay. And Clyde also says he's a fan of your G-Sender. He uses it on his Gatton CNC.
Cool.
Let's see here. Scott says, when you XYZ touch probe, can you tell it the size of the job in the XY datum and it will zero at that location?
I think the question is asking if you can use touch plate and then or do the homing process and then find the 0 point. There are a couple ways to do this. So if you're talking about the touch probe, you can, sorry, if you know the relation, if you use the touch plate and find the origin point, and you have an XY datum that's not at 0, 0, then you can move your machine manually to that position and either set a second workspace coordinate so that you can use in relation to that, how do I say? You can use it in relation to that original origin point, or you can re-zero after you've manually done it. And the same process applies to if you home the machine with the inductive sensors. Once you know the machine position, you can, if you know the relative distance to the machine's position, then you can just move it to that location. Or you can also, I believe you can also set machine coordinates and workspace coordinates manually in the DRO. So you can just go to, there's a lot of different ways to do this.
Yeah,
This is probably a little bit, yeah.
If I'm not mistaken, I believe you have the what I call offset coordinates, G54, 55, 56, on up through there. And I don't know how many you have in G-Sender, but I'm pretty sure you could home the machine. And then if you already know that maybe you've got a fixture in there and where your work coordinate needs to be, if it's, you could just hit that button and it'll go right to it if you've already preset it.
Yeah. And G-Sender has a drop down on the upper right side to choose your workspace coordinates. So yeah, go crazy.
Okay, Harry says, is your driver board designed to control both the laser and the spindle? Can you set up G-code to do a project that does both laser and carving?
I guess the short answer is yes. So the long board has a spin PWM output. That's the most common, that's the generic way for Gerbil to do the control. The PWM signal for laser and spindle are identical, so they come off the same plug. Generally speaking, we don't have a lot of customers that use spindle, so it's rare for them to need to duplicate the use for both. You could put them in parallel, so you have the same PWM signal going to both controllers, either to the laser or the spindle, and then you can set the maximum output scale of the laser in the laser software to match the spindle range. And then, yeah, then you can control both and you just turn on the one that you want to do. The other thing I believe that's being, so if you do want to use laser and carving at simultaneously, well, not simultaneously, you can do them one after the other. You need to know the offset distance for the laser and the end mill. One way you could do that is to burn a reference point on a material and then move the machine to that point and then record how much you needed to move to get to that point, and then use that coordinate in a second workspace so that when you run one, one type of job, like either the laser or the spindle, you can just switch between the workspaces to get the right positioning, or just manually move and re-zero to the laser location. Yeah, kind of a complicated answer.
Yeah. Okay, Scott says, I have one coming Tuesday. Is that going to be obsolete? I'm not sure.
He was talking about it was the touch plate.
Oh, okay.
No. So both touch plates will do this. Like, they fundamentally have the same purpose. You can use the same touch plate for the same thing. I guess to build on top of that, so early scoop, the new touch plate is called the Auto Zero touch plate. The main feature is that it'll find the dimensions of the bit to find its zero. So the old touch plate, you have to manually enter the size of the bit, sort to 0 accurately. This new one can just move on the touch plate and it'll calculate the size of the bit. The other thing, which is super, super cool, is that they work with ball nose and V bits, because if you guys aren't familiar, one of the big issues with touch plates is that you can't home tapered bits, ball nose bits, and V bits because they're not symmetrical in all directions.
Mm-hmm.
So yeah, watch out for that video. It's gonna be crazy.
Okay, that's I don't know of any other script that does that.
Yeah. There is something else to share. Like, so one of the things that we're always also worried about is makes, right? No, I'm not. You guys know what I'm saying. It's like they do now. We have a better thing now. The other thing seems less good. So
progress.
To save some buyer's remorse, the process to make the touch plates is very, very complicated. So it's going to be really expensive. So it's like a nice to have, but you may want to consider which one to buy based on the price. The process to machine the plates is very, very complicated, with the coatings being very complicated too. So yeah, that's just like a thing to know.
Mm-hmm. All right, Clyde says he's the visualizer on the G Cinder is awesome. I would agree. I would agree with that for sure. Bob Wood asks, how do you spell QEmoto? I think he was talking about the Cam Lab.
Oh yeah, Kirimoto is spelled KIRIMOTO. If you use the software tool, the software choosing tool, you'll probably show up there too. We actually have a whole list of just the softwares. You can find that there too, and a couple other alternatives if you want to look at other alternatives too.
Okay. Alan Hefferman says, have you considered using ball screws versus Acme threaded screws for drives?
Oh, of course. Yes. So for the LongMill, one of the reasons why we decided on using lead screws is cost. So the cost for the lead screw is about 1/5 of a ball screw. So that's kind of like a big thing. Yeah. The aim for the LongMill is to build a machine that's affordable and at that kind of price range. So, if you buy a machine in our price range, it will probably come with lead screws. If you compare performance, they have pros and cons. Also the lead screws are simpler to engineer with, because the structure of them is less complicated to use. So it also makes it simpler for people to assemble, and it leaves less room for people to mess things up. But the downside, obviously, ball screws are more precise. And
is that a nice way of saying they won't lose the balls out of the bearing?
Yeah, you sound like someone who's had to deal with that more than once.
Well, I haven't, but I've heard people say, doing the unboxing that's using a ball screw, they'll say, now don't let this, when you're getting ready to put this on, don't pull this off just to see what happens, because I can tell you what happens. All the balls fall out.
Yeah. So lead screws are just simpler to use and they're cheaper. So in this application, it kind of makes more sense, because it's just like less for things to get messed up and be expensive to replace. That's kind of like the gist of it. But that being said, we have other projects that use ball screws. The alt mill uses ball screws, and I also have a project that I've done it's related to CNC, but it's not like a public, like a consumer product, which is to make these machines that mill orthotic insoles for like a manufacturing application. Those use ball screws, and they get a huge amount of use. And I can say that they have their drawbacks too. Like you have to be more careful with the maintenance, and they can go out of line as well. So when you talk about some of the more expensive machines, the market is a little bit of a different category as well, because those people are they either have more experience with that sort of stuff, or they're willing to put more effort into keeping the machine running, or they have a bigger budget to allow for the replacements if or when they need to happen.
Okay.
Awesome.
Got one last question here, I think. Bill Jones says, can you show a piece of the extrusion? He's interested in how it bolts to the steel plates.
Oh, yeah, sure. I can move my camera here.
Okay.
I'm in the workshop right now. So I'm where we do a lot of the cutting and testing in the office. So that's one LongMill here. That's the extrusion, chunky as well. And then these are M5 25 millimeter 7 screws that go into the extrusion. Give me like 5 seconds, I can probably pull out a rail somewhere.
Okay, so is that just a tapped hole in the end of that extrusion?
Yeah, that's correct.
Yeah, take your time, because we got a couple of super chats.
Oh,
Dave,
okay. Let me
Okay.
acknowledge
Give me 1
those.
sec. I can see one right there.
Okay. Yeah, here's the spelling on that, Bob, if you're still out there. And thank you, JR, for your super chat. You
And
rock,
also
buddy. And Alan as well. Thank you all for the super chat. Appreciate it very much.
Yeah, so there's the rail segment, and then
Okay,
there's the hole
Yeah, there you go.
that they go into. So yeah,
that's nice looking.
I know. Nice. We also had to do a lot of testing to see if people are going to strip the threads out. But I think if they're 25 millimeters of thread, it's going to be kind of hard.
Yeah. That's one thing you do have to worry about when you're dealing with aluminum, is because some people like to crank down on the stuff and strip them out. So
yeah, we spend a lot of time to see how people can mess the assembly process up. Yeah, we call it anti-proofing, because I have a habit of managing to break something in a random way that they don't expect. I was putting together the bigger one the other day, and I couldn't get the bearing through. So I started with a hammer, and then I worked my way up to the blowtorch, and I pulled out the angle grinder. So now we know we need a QA process the bearings, otherwise, someone's gonna pull out the angle grinder.
Yeah. Okay.
Bob was also asking, what pitch of the Acme screws do you guys use?
The pitch is 2 millimeters per rotation. Okay. Yeah, 4-star.
Okay.
Yeah, I was going to say, I think I read somewhere on your website that it's a 4-star lead screw.
Cool.
All right. Any other questions? If you got any, get them in quick, because we are done, and we've kept Andy here for nearly an hour and a half, and he's been very gracious with his time and answering questions very completely. So I appreciate that.
Alan's got a question there, Dave.
Okay, let's see. Oh, yeah, that's a good question. Do you cut the aluminum extrusions to length in your shop, or do you buy it pre-cut?
We get raw lengths that are about 3 meters long. Nice. The reason for that is because a 30-inch working area size rail is roughly 990 millimeters long. So you can get 3 out of 1 3,000 millimeter piece. And then a 48 size machine uses a rail that is 1,450 millimeters. So that goes into 3,000 twice. with some change. So we get them in raw lengths of about 3,000 millimeters, a little bit longer because we need the space for clamping. We have like an industrial, like, what do you call it? It's
Like
like
a
a
chop
miter.
saw?
Yeah, it's like a chop saw, but like 3-phase, like weighs like like 800 pounds, and they chop the aluminum. And then we have gauges for checking squareness. And then if it doesn't pass the squareness check, there's a mill over there that does the surfacing on each end.
Okay.
So we cut them to size. We can store the raw lengths and then adjust how many we cut of each size based on how many sales we get of each size.
Mm-hmm.
I think I like, in general, Dave, with all of our shows that we do and stuff, I really like understanding like the background of the functioning of the company. I always find that really fascinating. Like even the buying the lengths of the extrusion and stuff, which makes total sense because if you're ordering as much as you guys have to order to build all the kits that you do, it also makes logistics sense. Not to be paying somebody else to cut it. It's a whole lot cheaper for you guys to cut it, and you can make it to whatever you need it to be. So I like all the background stuff.
Mm-hmm.
Yeah,
I mean,
and if go ahead,
sorry,
Andy.
oh, I was just gonna say, like, I can get even deeper on this whole like debate on cutting the extrusions or not, if you want. I live this life these things happen every day, and we have to make these sort of decisions. So I know
it's engineer brain.
Yeah. Like we're all engineers here. Like that's our first and foremost thing,
Yeah.
Like so. I don't know if you guys know, but extrusions is like the supply chain for extrusions is like absolutely nuts. I called so that this last batch is enough for about 500 units. They told us that we had a 13-week lead time, so it went from 4 weeks to 13 weeks.
Mm.
And me being like, oh, it usually takes 4 weeks, was like, okay, cool. I'll just order it like 2 months in advance because that'll give us much more time than we need to, get those rails. But given, the pandemic, now that I got hit with the 13-week thing, it was like, damn, where am I going to get these rails? And I called 2 other extruder shops, and they were like, we are so busy that if you're a current customer, your lead time this was back in November of 2021. You're going to wait till August of 2022 at the minimum. At the minimum to do it. Right? So I was like, okay, well, that's not going to work. Luckily, Almeg, which is the company that does the extrusions for us, they did it in about 4 or 5 weeks because they rush ordered it for us. So we managed to get those earlier. And obviously now that we know this 13-week lead time, we order the extrusions way in advance. But so not only does the extrusion, this is a press time. So this is a time for the order from us to get into the pressing schedule. But then after that, it has to go to the machine shop to be cut and processed, which can take another 2 to 3 weeks. So we thought, okay, well, we don't need all the rails all at once. If we can just cut them as we need them, we'll just cut them as we need them. So we cut 100 rails in a day, and we use up the 100 rails. Then we can get all those rails in earlier, and we can kind of just spread over the work over the maybe 2 or 3 months that we need the rails for. So that was another decision for us to invest in buying the saw. Also, the outsourcing costs for cutting to our precision was quite expensive. We were looking at anywhere from $30,000 to $40,000 per 500 units to do that process. So we're like, okay, well, if we had $30,000 or $40,000, could we do it ourselves and save some money?
Yeah.
Uh,
Just hire somebody. That's all they need to do.
well, it wasn't as simple as that, because we had to find what saw we needed, and then we need to find how to make it square. And then once we measure it to that length, we need to also figure out, if it's not square, what do we do with those rails? And then do all of those like things at once. Yeah, so that was kind of a process. I am also proud to say that we managed to find a saw from a business that was not shutting down, but like starting to like scale back. It was gonna be like a $10,000 to $15,000 saw for like $1,500, you know.
Oh, yeah.
So that was like, after that, I was so happy.
Yeah, I bet. All right. Well, man, I have really enjoyed talking with you, Andy. Again, thank you so much for coming on the show here. And for the folks out there watching, if you haven't got enough of what you learned tonight, I would recommend going to the CNC Labs YouTube channel and check out some of their videos, particularly the one where Chris is doing the tour shop. I guess it's the shop tour, and you can see the printer farm, and he talks about pretty much everything, the way they do things. And I'm very impressed, and wish you guys continued success.
Yeah, and I should mention that video, I think, is when we didn't expand to the other side yet. And I think our shop is maybe 2 to 3 times larger than that video. Yeah, so.
Yeah, that's the thing. That video was a while ago. So I think, in fact, he comes over to that other part and opens the door, but it's basically empty because the landlord had just moved out or something. And, you know, he said you're going to be setting up some stuff in there, but yeah, really not seeing everything the way you have it now, I guess.
Mm-hmm. Yeah, maybe it's time for another video. Who knows?
All right. Well, thank you so much for joining us tonight, Andy. I really appreciate it. And thanks to all the folks that have tuned in tonight and asked questions in the chat and stuff. I appreciate you guys, and especially Alan and JR for the super chat. Much appreciated. And I guess if we don't have any other questions, we'll wrap up and let Andy get out of here, because I know he's probably got to go to work tomorrow.
Oh, no, tomorrow's Sunday.
Oh, that's right. That's right. Well, you guys are so busy. I figure you'd be working 7 days.
You know, that's like we being, like, for me and Chris being the founders, we know how important work-life balance is. So sometimes I'm here, but I'm working on my own projects. I like to, I have a car that I'm in the process of restoring. So that's like that's my personal thing, you know. And I'm lucky I have all these machines to play around with. So I like to come back here to make my own stuff.
Okay. Well, see, I'm even more impressed now, because that just shows you it's a great place to work, because you get weekends off.
Yeah, maybe. I see Kelsey's on the chat too. She says work-life balance. Why are you watching a company podcast on your weekend? I'm just kidding. I appreciate the support.
Yeah, we appreciate you, Kelsey. All right. Well, we're going to get out of here then, if nobody else has any other questions. And again, thank you so much for joining us. And we will see y'all next week. Oh, before I forget, next week, I have been scouring the different Facebook groups, finding all of these awesome CNC projects people are doing. So we will be doing another one of I call them the show and tell type shows, where we have a ton of projects to show. And man, you guys just continue to impress me with all the awesome stuff you guys make with these machines. So be sure and come back next week and check that out too. All right, we're out of here. Thank you, Ryan. Thank you, Andy. We will see you all next week. Have a good weekend, everybody.